In this video, we're going to look at another example of using U substitution to evaluate an integral. And the integral is we want to evaluate the integral of the square root of 1 minus sine of 2x. We're going to use two different methods to show how to do this. So here's method 1. This one will use U substitution. So we're going to multiply square root of 1 minus 2x and multiply and divide by the square root of its conjugate, which is the square root of 1 plus sine of 2x. And of course we have to divide by square root of 1 plus sine of 2x. This is a form of 1, so we're not changing the problem. So this would be in the numerator square root of 1 minus sine of 2x times 1 plus sine of 2x. And in the denominator, we have the square root of 1 plus sine of 2x. And the square root of the numerator, that is the square root of 1 minus sine squared of 2x divided by the square root of 1 plus sine of 2x. Of course, 1 minus sine squared of 2x is cosine squared of 2x divided by square root of 1 plus sine of 2x. And we can take the square root of cosine squared of 2x to be cosine of 2x divided by square root of 1 plus sine of 2x dx. And here we can now evaluate this by using U substitution. So we have the integral of cosine of 2x over the square root of 1 plus sine of 2x. Let u equal to what's in the square root in the denominator, 1 plus sine of 2x. Du is 2 cosine of 2x dx. So 1/2 du equals cosine of 2x dx. Now let's rewrite this in variable u. The numerator is cosine 2x dx, which is 1/2 du over square root of u. And this is a basic integral, 1/2 times the integral of u to the minus 1/2 du. So this is 1/2 u to the 1/2 over 1/2. 1/2s cancel. And this is just u to the 1/2 power, or square root of u plus c. And so we can conclude that the integral of square root of 1 minus sine of 2x dx equals square root of u. Remember what u was, it's at the top. It's square root of 1 plus sine of 2x plus c. So this is good enough as far as the answer, but we can simplify it and make it a lot nicer by using some basic trigonometry. So let's go ahead and do that. 1 plus sine of 2x, recall sine of 2x is 2 sine x cosine x. So we're using this trigonometric identity. And then recall that 1 is sine squared of x plus cosine squared of x, and then plus 2 sine x cosine x. And you can see the quantity inside the radical can be written as cosine squared of x plus 2 sine x cosine x plus sine squared of x plus c. And if you look carefully inside the square root, that's a perfect square. That's cosine x plus sine x squared plus c. We can cancel the square root and the square and have our final answer cosine x plus sine x plus c, which is a very nice answer in a very simplified form. Now let's look at method 2. Method 2 requires no U substitution at all. It requires trigonometric identities, just like we did here at the beginning of the problem. So here's how we would do it. Integral of square root of 1 minus sine of 2x dx. Once again, we're going to replace sine of 2x with 2 sine x cosine x. So this is the square root of 1 minus 2 sine x cosine x dx. Once again, we're going to replace 1 inside the square root with cosine squared of x plus sine squared of x, and then minus 2 sine x cosine x dx. Let's rearrange these one more time and then proceed to solve the problem. This is equal to square root of cosine squared x minus 2 sine x cosine x plus sine squared x dx, which of course is a perfect square. Square root of cosine x minus sine x squared dx. And that becomes the integral of cosine x minus sine x. And of course, integral of cosine x is sine x. Integral of negative sine x is positive cosine x. And now we add c. And of course, we get the same answer that we got when we use U substitution.